Okay, we'll go ahead and get started with our notes today on 9.4 quadratic applications. We have 3 word problems to do. So our first one will be using the Pythagorean theorem. So a little geometry review here. All right, so we'll do one example of this. You have a couple in your homework. So 2 cars left at an intersection at the same time. It's not a distance, rate, and time problem if some of you are getting nervous. One heading north, the other due west. Later, they were 100 miles apart. The car headed north had gone 20 miles farther than the car headed west. And then our question, how far had each car traveled? All right, so it could be helpful to draw a little picture here. So they didn't tell us about, we really only know distances. So we are just creating this picture and we're just gonna use those distances for how far they went. So we've got, they're leaving, 2 cars left at an intersection at the same time. One went north, the other went west. And the car headed north went 20 miles farther than the other car. They were 120 miles apart, so it's making this little right triangle. We don't know how far they went west. We know this one went 20 miles farther than the one going west, if that setup makes sense. All right, then if you remember the Pythagorean theorem, I take a squared plus b squared equals c squared. Remember, these are the legs of the triangle, so those would be the cars going north and west. C is your hypotenuse, that longest side across from your right angle, so that's going to be my 120, and then I'll fill this in. So I've got x squared plus x plus 20, that whole quantity squared, equals 120 squared.
Why isn't it 100?
The hypotenuse was 100. Oh, I don't know. Yeah, I should be using 100. I don't know if I just added the 20 to the 100. I don't know. I got to use the information from my problem. Perfect, thank you. So then, from here, I'm just doing Pythagorean theorem. So I'll keep the x squared. Remember, if I'm squaring the whole quantity, x plus 20, I need to write that out twice so that I distribute everything. and make sure that I am taking it times itself. I'm not just squaring the x or squaring the 20. That's not squaring that entire quantity. All right, then 100 squared to be 10,000. And then I'll go ahead and distribute here. So I'll keep my x squared plus another x squared plus 20x plus 20x and plus 400 equals 10,000. All right, so the biggest mistake I see when students do this problem is they do not write this out twice. So then they will end up missing that 20x plus 20x, which will then give them the wrong answer in the end. All right, so just be careful about that part. Let's combine our like terms now. So I have a 1x squared plus 1x squared would be 2x squared. 20x plus 20x would be 40x plus 400 equals 10,000. So this is a quadratic equation. Make sure you get everything on one side equal to 0. So the fastest way to do that would be to subtract 10,000 to the left side. So I'll have 2x squared plus 40x minus 9,600 equal to 0. Oops, I'm missing my x. All right, so now we're solving this quadratic equation. So it's up to you how you want to solve from here. We've talked about factoring, we've talked about quadratic formula. So when you're doing the problems, it's your choice. Whether you're going to choose quadratic formula or factoring, you can always factor out a greatest common factor if that helps you to see if it's factorable, or if it just helps you to work with smaller numbers for your A, B, and C to plug into your quadratic formula. So right now I can see that I could divide every term by 2. So I try to pull out common factors if I can, just so I can work with something smaller. So I've got x squared plus 20x. 9,600 divided by 2 would be 4,800. All right, this one is factorable. Maybe you can see it right away. Maybe you wouldn't see it right away. So then you'd still use your A would be 1, your B is 20, your C would be your 4,800. All right, it would give you the same answers if you use 2, 40, and 9,600. So it's up to you if you were choosing quadratic formula, if you just made it easier with pulling out the 2, or if you thought that was extra work that was unnecessary. I like to work with smaller numbers, but maybe you can spot the factors, maybe not. But we would use 60 and 80. All right, 6 times 8 would give me 48, then the 2 zeros. 60 and 80 are 20 apart. I would need a positive 80 and a negative 60. All right, so x plus 80 equals 0. X minus 60 equals 0. So I get 60 and negative 80. Remember, we're dealing with a word problem where we have a distance. So negative 80 shouldn't make sense. 60 looks like should be the winner. And if we go back and check, it asked us to figure out how far each car had traveled. So this was the car going west was our variable. So if it says how far did the car travel going west in your program, you would say 60 miles. And then how far would have been the car that traveled north? Would have been 80 miles because that was 20 miles further. And then you can always check 60 squared plus 80 squared would equal 100 squared. Okay. So those problems will be a very similar setup. Some of them are going to give you the triangle setup, give this picture to you already, and then you know to set up that Pythagorean theorem. Biggest thing is make sure you put that whole quantity squared, you write it out twice, and you distribute. Otherwise, it shouldn't be anything more difficult than what we had to do last week. Okay, not that it's easy, but not anything more difficult than we've already been trying. Okay. All right, we have 2 more different types of examples that you will see. All right, the next one is solving an area problem. These are ones that I see a lot. I see a lot of these on practice ACT tests, MCAs, that kind of stuff. So these are kind of ones that just randomly pop in here and there. So our example is a couple wants to buy a rug for a room that is 20 feet long and 15 feet wide. They want to leave an even strip of flooring uncovered around the edges of the room. And then here's our question that we're going to try to solve. How wide a strip will they have if they buy a rug with an area of 234 feet squared. And that's our problem. So my suggestion for these ones would be, once again, to sketch a picture if one is not given to you in your problem. So we've got a room, and the room is 20 feet long by 15 feet wide. All right, they're trying to find a rug that's going to be in the middle of the room. Its area is 234 feet square. And they want to know how much space would be left uncovered around each edge if that was an equal amount, so it looks all nice, right, on each side. This would all be the same distance, and that's what we're trying to figure out, is how wide or how big that strip would be. Okay? So when we have problems similar to this, they're going to give you one area. Whether they gave us the area of the room, we could figure out the area of the room, or they give you the area of the rug. I always set my problems equal to the area that they gave me. Right? I gotta set up some kind of equation, so I need equal to something that we know. So I like to set it equal to the area that's been given. So then I gotta think about, well, the area is length times width for a rectangle. All right, so I'm trying to figure out this right here, but more importantly, how would I come up with the area with what's been given to me, because I don't know the exact length and width of my actual rug. So that's what I got to think about. I'm taking this length times that length to get 234. So if this is 20 feet long, I need to take away this piece and this piece to get the length of the rug. So it was 20. I'm taking away not 1x, but 2 x's from the total length of the room. Right? If I knew the strip, how long the strip would be of the floor, I would subtract each one of those from the 20 feet that I have. That would give me the length of my rug. All right, so that's going to represent the length of the rug. I need to multiply it by the width of the rug. So similar concept here, but now we are using the 15 feet because that's the width of the room. And I need to take off 2x from that because that would be my each of those extra sides of the flooring. All right, and that will be our equation. This length times this width would give me the area of the rug. So then from here, I will distribute. So I'll take 20 times 15, so 300 minus, where am I going? Minus 40x minus 30x plus 4x squared equals 234. So go ahead and combine your like terms. So 300 minus 70x plus 4x squared equals 234. So I want to subtract the 234 to the left side so I can get all this quadratic equation equal to 0 on one side. I'm going to reorder it a little bit. So I've got 4x squared in front minus the 70x, and then I'll take away 234 from my 300, so I'm left with 66. All right, we've got your quadratic equation again. So up to you at this point. Are you going to put this into your quadratic formula right now? Are you going to factor out a greatest common factor of 2 and then see if you can factor it after that? That will be up to you, but I like to make them smaller to work with. So I'm going to factor out 2. So that would be 2x squared minus 35x plus 33. All right, now some of you might just jump to quadratic formula because you don't want to deal with an a value that's larger than 1. But when I look at this and I have it has to multiply to 33, that's only 3 and 11, or 33 and 1, and I have to combine to 35. So maybe some of you can see it, but it is factorable. And maybe it would take you a long time to factor, but I knew this would be 33 and 1, because when I take 1 times 2, I'll get 2. 33 times x is 33, and then they will be, oh wait, am I doing the signs wrong? No, I'm doing okay. And then they'll both be negative, so I'd have negative 2 minus 33x would give me negative 35x. You could have done quadratic formula, totally fine. Oops. So x would equal 1. Over here, if I add 33 divided by 2, so 33 halves, or 16 and a half feet. So you got to think about, now it's not both of them. Which one would make more sense? Well, this little strip here and here better not be longer than the actual room, right? So think about it for a second. It is 1 foot. Okay, you can always plug that back in and double check that that would make sense. Right, if all of these are 1. Okay. All right, we'll do one more example here. So the last one would be solving a projectile problem. These are probably the most common word problems that you did in Algebra 2. So maybe this will be familiar to you. So the function f of t equals negative 16t squared plus 112t plus 144 is the position of an object in feet above the ground. Where t is the time in seconds after the object was projected. When is the object (200 feet off the ground? We talked a lot in Algebra 2 about when will the object reach the ground, when is it a certain height off the ground, that sort of situation. This type of problem should hopefully look familiar to you. That negative 16t squared came up a lot. That has to do with gravity when we are in feet per second. All right. If you remember 144, that's your y-intercept on a graph. That's where it would start. So it's at a height of 144 before it begins. The 112 had to do with the velocity, all right, that the object is going. All right, so the 200 feet is representing my f of t. All right, that's my output. That's going to give me whatever the height is at a certain time, but we don't know the time t. So I'm filling in the 200 in place of f of t, and then I have to solve for t. All right, so setup should be a lot simpler than the last two. You're just given whatever height they gave you and setting it equal to that equation. Then I'll need to subtract 200 over, get it equal to 0. So I have 0 equals negative 16t squared plus 112t and then minus 56. All right, you're welcome to attempt to factor this, but it is not factorable, so I'll just give you that hint, don't do it. Typically these problems with those negative 16t squareds are messy, so I rarely try, and I just start setting up my, in this case, t equals, my opposite of b would be negative 112 plus or minus. I'll need to take 112 squared, so I might just write that down right now, is 12,544 minus 4. My a is negative 16, my c is negative 56, and that's all over 2 times my a value of negative 16. All right, so I want to calculate with inside of that square root here first. So I already did the 112 squared. Let's take the negative 4 times negative 16 times negative 56. That will come out to be a negative 3,584. So I'm subtracting those two values inside of that square root. So equals negative 112 plus or minus inside of the square root, you should get 8,960. And we're dividing that by negative 32. And then from here, it's a lot of calculator work. to come up with those two solutions. So oftentimes our word problems, one of them doesn't make sense. Both of these answers will make sense. So you're typing in negative 112 plus the square root of 8,960. Find that answer, then divide it by negative 32. And for your second solution, negative 112 minus the square root of 8,960. Then make sure you find that answer and divide that by negative 32. You'll get messy answers. So this will be one where we will go up to some decimal places. I put it up to 2 decimal places, so 0.54 and 6.46 is what you should get for your two solutions. And we're in time, so these are in seconds. All right, so this is a case where two solutions do make sense. If you remember, we did some sketching in Algebra 2 about these types of graphs. So I've got a parabola as a quadratic. It has a negative a value, so it's going to be one of those upside down parabolas. So 144 is the c value, or the starting height. So this is just a quick little sketch or idea here. So it does hit 200 in more than one spot on the graph. So the time's on the bottom, remember. So there would be 2 times, right? Somewhere earlier on and then somewhere later on. All right, if that makes sense. Okay, we had to do things like we had to find the vertex, find that maximum height, find the y-intercept, find these pieces in Algebra 2. Okay. All right, those are the 3 different type of examples you will see in your homework. Today's the last day we're dealing with quadratic equations, and then we'll take a little break from that in our next 2 lessons to come. So good luck with your homework.